Okay. Hello, everyone. How are you? We have already talked about in this chapter the requirements engineering. We have talked about the difference between functional and non-functional requirements.
Lao Xu.
Yeah. Kaya.
Functional requirements should be requirements that describe the functionality of a system, and then in doing that, like for instance, let's say we are working at we are all doctors and they are nurses and so on. So functional requirements would be we need a place where the nurses can interact with the software, and a place where the doctors can interact with the software, where they can gather information from and so on. That's a functional requirement, where it's part of the function of the system. I don't know if that's correct or not.
Pardon for non-functional requirements.
Non-functional requirements are like let's say a system needs a particular IDE, or for instance a certain IO that the system might need. Those are non-functional requirements that are critical with the system itself and how the system runs. Those are non-functional requirements.
Yeah. Thank you very much, Kaya. Yeah. Your explanation is very precise and very correct. Correct. Yeah. Thank you very much, Kaya. As what said by Kaya, functional requirements are some services that the system will provide, and non-functional requirements are about some. Yeah, it's like some. It's like the performance, the security, or availability, etc. is some specific demand delivered by the system to its user. What's the difference? Russell, it's you? Yeah?
Yes, it's me. I'm sorry.
It's okay. It's okay. So we see the difference between functional and non-functional requirements. And for the non-functional requirements, we have also we have introduced a classification of non-functional requirements. For the three non-functional requirements, three types, we have product requirements, organizational requirements, and external requirements. Perfect. Thank you, Roy. No, thank you, Faisal. I'm sorry. And then we have talked about different users of requirements document. We have said we may have different users, different end users, like system customers, managers, system engineering, etc. Also, we have shown different ways of writing a system requirements specification. We said it's better to use natural language to write a requirement specification, as we need to share the document between customers and developers. We may use also structured natural language, design description language, graphical notations, mathematical specifications. Later, we have also talked about the requirements engineering process. What is essential is to keep in mind that, we have 4 activities in requirements engineering processes. And for the requirements engineering processes, as we said in the second chapter, at first, we should do a feasibility study to see if the system is useful to the business or not. Yeah, do you remember? Later, we have to discover we have to discover, we can say discovering requirements. Then we have the, here the discovering requirements is like what is said by you, what you have said, this elicitation and analysis. It's discovering requirements is the same as elicitation and analysis. Later we will convert these requirements into some standard form, so we use specification. Activity is to check if the requirements actually define the system that the customer wants. It's the validation. That's the 4 activities included in the requirements engineering processes. Requirements validation is the process of checking that requirements actually define the system that the customer really wants. It is the definition of the requirements validation. Here, this activity sometimes it overlaps with analysis, as it is concerned with finding problems with the requirements. And this activity, requirements validation, it is important because errors in a requirements document can lead to extensive rework costs. And when these problems are discovered during development or after the system is in service. So in order to not pay high costs of the requirements error, it's better to pay attention to this activity, requirements validation. And we can also, here we have a description. Fixing a requirements error after delivery may cost up to 100 times the cost of fixing an implementation error. It's to say that this requirements validation is very important. And during the requirements validation process, we have different types of check to carry out on the requirements in the requirements document. These checks include, the first one is the validity checks. We should ask, does the system provide the functions which best support the customer's needs? Here, for the validity checks, a user may think that a system is needed to perform certain functions. However, further thought and analysis may identify additional or different functions that are required. Systems have diverse stakeholders with different needs, and any set of requirements is inevitably a compromise across the stakeholder community. So, with the validity checks, we can have an idea of the functions to support the customer's needs. And then we should check the consistency. That means, are there any requirements conflicts? Normally, requirements in the document should not conflict. That means we should not have contradictory constraints or different descriptions of the same system function. And the next check is the completeness check. Are all functions required by the customer included? Here, normally the requirements document should include requirements that define all functions and all the constraints intended by the system user. And the requirements should be realized. So we need to ask, can the requirements be implemented given available budget and technology? Normally, we use knowledge of existing technology. The requirements should be checked to ensure that the requirements can be implemented. So we need to take account of the budget and schedule for the system development to do this check. And the fifth check is the verifiability. We should see if the requirements can be checked. As we know, there may have some disappointments between customer and us developers or contractors. So to reduce the potential for dispute between customer and a contractor, system requirements should always be written so that we can verify these requirements later. It means that we should be able to write a set of tests that can demonstrate that the delivered system meets each specified requirements. These different points or different checks are to guarantee that we have perfectly the requirements document can satisfy the customer and the developer. We have also a number of requirements validation techniques. These techniques can be used individually or in conjunction with one another. That means we can combine several techniques together. Here we introduce 3 techniques. Requirements reviews, which is the systematic manual analysis of the requirements. Here, the requirements are analyzed systematically by a team of reviewers who check for errors and inconsistencies. And the second technique is the prototyping. Prototyping, we use an executable model of the system to check requirements. In this approach to validation, an executable model of the system in question is demonstrated to end users and customers. That means we will demonstrate an executable model. This model will demonstrate it to end users and customers. Then the stakeholders or end users, they will experiment with this model to see if this model meets their real needs. That's the purpose of the prototyping. The third technique is the test case generation. Here is to develop tests for requirements to check testability. We should test the requirements. If the tests for the requirements are devised as part of the validation process, this often reveals requirements problems. If a test is difficult or impossible to design, this usually means that the requirements will be difficult to implement and we should reconsider the requirements. So you see, it is difficult to show that a set of requirements does in fact meet a user's needs. Users need to picture the system in operation and imagine how the system could fit into their work. It is hard even for skilled computer professionals to perform this type of abstract analysis, and harder still for system users. So for us, we should find all requirements problems during the requirements validation process. In this way, there will be But as we said before, some further requirements changes are inevitable. As with these changes, we can also correct omissions, and we can also make up some misunderstandings of the requirements document. That's the use of requirements validation. Yeah, for this part, the requirements validation, we should know the five types of check to carry out on the requirements in the requirements document. Also, we have introduced 3 techniques of the requirements validation. Now we'll pass to another section, which perhaps will be interested by many people, is the requirements management. You have talked about this before, and here we concentrate on the requirements management, especially for the changing requirements. As we know, requirements management is the process of managing changing requirements during the requirements engineering process and system development. We know that the requirements are always changing, especially for large software systems. And one reason for this is that these systems are usually developed to address weak problems. That means some problems that cannot be completely defined. As we cannot fully define the problem, the software requirements are usually incomplete. So we may always have new requirements emerge as a system is being developed and after it has gone into use. That means either we will discover new requirements during the development or after delivering it to end users. So we need to keep track of individual requirements and maintain links between dependent requirements so that we can assess the impact of requirements changes. That means we need to establish a formal process for making change proposals and linking these proposals to system requirements. Here we have several reasons to see why change is inevitable. The first reason is that the business and the technical environment of the system always changes after installation. Yeah, as in our business company, especially for large scales, new hardware may be introduced, and it may be necessary to interface the system with other systems. Also, we may have some business priorities that may change, and in consequence, we will have changes in the system support required. We may also have new legislation and regulations. If we introduce these new legislation and regulations, we must change the system to adapt to it. The second reason is that the people who pay for our system and the users of that system are really the same people. That means, we may have system customers who impose requirements because of organizational and budgetary constraints. However, their requirements may conflict with end-user requirements. So after delivery, we may have new features to be added for user support if the system is to meet its goal. So you see, as we have said before, if we have various stakeholders, we may have conflicts, we may have requirements that may be in conflict with each other. Also, the third reason is that large systems usually have a diverse user community, with many users having different requirements and priorities that may be conflicting or contradictory. The final system requirements are inevitably a compromise between them, and with experience it is often discovered that the balance of support given to different users has to be changed. Yeah, here this one is a little, yeah, we have some intersection with the last one. That means different stakeholders or end users may have different requirements. Here, this figure shows the stakeholders' understanding of the problem. We see that this understanding is constantly changing during the software process. At first, we may have an initial understanding of the problem, and this will lead to our initial requirements. Later, with the time, we may change our understanding of the problem. In this way, we may have some requirements to be changed. And so that's why the system requirements must evolve to reflect this changed problem view. When we want to manage the requirements, when we talk about the management of requirements, we have an essential first stage in the requirements management process. That is the planning. Planning stage, it establishes the level of requirements management detail that is required. And here we have listed some decisions to make during the requirements management stage. The first decision is the requirements identification. In this one, each requirement must be uniquely identified so that it can be cross-referenced with other requirements. That means we should identify each requirement at this stage, and we should make clear the relationship between requirements. And also this requirements identification may be used in traceability assessment. We'll talk about this one later here. And the second decision to make during this stage is a change management process. This is the set of activities that assess the impact and the cost of changes. That means this decision will see how the changes will impact the system, and how the changes, if we implement the changes, the changed requirements, how much will cost us the time, etc. Then the third one, traceability policies. These policies define the relationship between each requirement and between the requirements and the system design that should be recorded. Here, this traceability policy should also define how these records should be maintained. Then we have the fourth decision, to be made is the tool support. Tools that may be used range from specialist requirements management systems to spreadsheets and simple database systems. In fact, requirements management involves the processing of large amounts of information about the requirements. That's why we may have various tools and ranging from, in general, big management systems to spreadsheets or simple database systems. These are some decisions to be made during the requirements management stage. As we see that change management is essential because we need to decide if the benefits of implementing new requirements are justified by the cost of implementation. We need to decide whether we will accept whether we will accept a change management or not. No, whether we will accept a change to the requirements or not. Here we have some principal stages to decide if a requirements change should be accepted or not. The first stage is to see is the problem analysis and the change specification. During this stage, the problem or the change proposal is analyzed to check that it is valid. Here, this process starts with an identified requirements problem, or sometimes this stage starts with a specific change proposal. And during, as said here, during this stage, we will analyze the problem or the change proposal to see if it is valid. This analysis is fed back to the change requester, who may respond with a more specific requirements change proposal or decide to withdraw the request. Then we will see the change analysis and costing. Here, the effect of the proposed change is assessed using traceability information and general knowledge of the system requirements. That means here, the cost of making the change is estimated both in terms of modifications to the requirements document, and sometimes we will also estimate the cost of change to the system design and implementation. If the analysis is completed, we will make the decision whether or not to proceed with the requirements change. And the third one is the change implementation. Here, the requirements document and where necessary, the system design and implementation are modified. Ideally, the document should be organized so that changes can be easily implemented. That means here, to implement the change, we should at first do a requirements document. We will organize this document so that we can more easily it will be more easily to implement the changes. That means we can make changes to the original system without extensive rewriting or reorganization. Especially for the requirements document. This figure shows the requirements change management process. This process should be applied to all proposed changes to our system's requirements. After the requirements document has been approved. You see, we have identified the problem, then we begin to have the stage problem analysis and change specification. Later, we have change analysis and costing, then we change implementation. At the end of this stage, we get the revised requirements. Okay, this is for this point. You see, here, when we talk about the management of the requirements, we always talk about management of changing requirements. Yeah, it's the end of the process, and you see, even during this process, we have different stages, including analysis or other things. This stage is a supplementary to, for me, it is a supplementary activity of the process, and we cannot put it independently as a core activity in the process. That's why, yeah, when we ask for the 4 activities of the requirements engineering process, for me, it's better to write the 4 activities as a feasibility study, discovering requirements, specification, and validation instead of this activity. Yeah, that's my argument. Now we'll have a summary of this chapter. In this chapter, we have talked about the requirements engineering. Requirements for a software system set out what the system should do and define constraints on its operation and implementation. So you see here, we may have what the system should do, like the functional requirements, some constraints on its operation and implementation. It may include some non-functional requirements here. Yeah, now we have the definition of functional requirements. They are statements of the services that the system must provide, or are descriptions of how some computations must be carried out. So you see here, for functional requirements, we talk about some services. We consider the system as a total. So we have the services provided by the system, and we have some information about the calculation or and some description of the computations. For non-functional requirements, they often constrain the system being developed and the development process being used. Here, these non-functional requirements might be product requirements, organizational requirements, or external requirements. As what we as said by at the beginning of the class, I think it was Faso. Yeah, Faso has completed these 3 types of non-functional requirements: product requirements, organizational requirements, or external requirements. These non-functional requirements often relate to the emergent properties of the system and therefore apply to the system as a whole. So we see that for functional requirements, they are rather for services, and non-functional requirements, they are rather for the properties of the system. Yeah, here we say the non-functional requirements often relate to the emergent properties of the system and therefore apply to the system as a whole. Later, we have the software requirements document. It's an agreed statement of the system requirements. It should be organized so that both system customers and software developers can use it. That means, we should organize the system, the software requirements document in the way that, both customers and developers can use it and are agreed with it. I'm sorry, already had a break. What? I'm sorry.
He was just joking.
Okay. But here is about the software requirements document. We say it should be a document shared by customers and developers. Okay, here we have repeated the requirements engineering process. We say that it is an iterative process including a feasibility study, requirements elicitation and analysis. Yeah, you can add it or not. Requirements elicitation and analysis, specification and validation. Here we can also say discovering requirements for the second step. And the next point is that we can use a range of techniques for requirements elicitation. These techniques can include interviews, scenarios, use cases, and ethnography. Yeah, we have talked about this last week. Then we have seen that requirements validation is the process of checking the requirements for validity, consistency, completeness, realism, and verifiability. This one is the different types of check that should be carried out on the requirements in the requirements document. Yeah, we should check these 5 properties during the requirements validation process. And the last point in this chapter is that business, organizational, and technical changes inevitably lead to changes to the requirements for a software system. And requirements management is the process of managing and controlling these changes. Okay, this is about this chapter. Now we'll continue with our 5th chapter. In the 5th chapter, we'll talk about the system modeling. And the aim of this chapter is to introduce some types of system model that may be developed as part of the requirements engineering and system design processes. And after reading this chapter, normally we should understand how graphical models can be used to represent software systems. That means we should understand how we can use different graphical models to represent software systems. We should understand why different types of model are required and the fundamental system modeling perspectives of context, interaction, structure, and behavior. Yeah, here we will introduce some of the diagram types in the Unified Modeling Language, UML, and we may use, after reading this chapter, normally we may use, we should understand how these different diagrams can be used in system modeling. Also, we should be aware of the ideas underlying model-driven engineering, where a system is automatically generated from structural and behavioral models. Precisely in this chapter, we will talk about 5 topics. The first one is the context models. The second one is the interaction models. Third one, structural models. Fourth one, behavioral models. And the fifth one, model-driven engineering. These are the topics covered in this chapter. First, we'll see the definition of system modeling. System modeling is the process of developing abstract models of a system. Each model represents a different view or perspective of that system. So you see, we may have different models of a system. System modeling has now come to mean representing a system using some kind of graphical notation. Yeah. Now, almost always we are based on notations in the unified modeling language. And system modeling helps the analyst to understand the functionality of the system, and models are used to communicate with customers. As we have said before, often we use some diagrams to communicate with customers, as it is a natural language which can be more easily to be understood by people from different backgrounds. Models of the existing, when we develop models for a system, we may develop models of both the existing system and the system to be developed. Models of the existing systems are used during requirements engineering. And these models help clarify what the existing systems does and can be used as a basis for discussing its strengths and weaknesses. These models can lead to requirements for a new system. And models of the new system, often we use these models during requirements engineering to help explain the proposed requirements to other system stakeholders. And in a model-driven engineering process, it is possible to generate a complete or partial system implementation from the system model. Here, we may develop different models to represent the system from different perspectives. Here we have listed 4 perspectives. The first one is an external perspective, where we model the context or environment of the system. A second perspective is an interaction perspective, where we model the interactions between a system and its environment, or between the components of a system. A third perspective is a structural perspective. We model the organization of a system or the structure of the data that is processed by the system. The fourth perspective is a behavioral perspective. There, we will model the dynamic behavior of the system and how it responds to events. So we see here the 4 perspectives are quite different, with external perspective to model the context and the environment, interaction perspective to model the interactions between the system and the environment or the components of a system, structural perspective to model the organization of the system or structure of the data, and behavioral perspective to model the dynamic behavior of the system. As we have said multiple times, for the system modeling, we use commonly the diagrams defined in UML. And UML diagrams have become a standard modeling language for object-oriented modeling. The UML has many diagram types and supports the creation of many different types of system models. And most users of the UML thought that 5 diagram types could represent the essentials of a system. The first diagram type is the activity diagrams. With this diagram, we can show the activities involved in a process or in data processing. We have the use case diagrams to show the interactions between a system and its environment. We have the sequence diagrams to show interactions between actors and the system and between system components. We have also the class diagrams, which shows the object classes in the system and the associations between these classes. The last diagram type is the state diagrams to show how the system reacts to internal and external events. You see these 5 diagram type. Activity diagrams is to show the activities involved. Use case diagrams to show the interactions between our system and the environment. Sequence diagrams to show the interactions between actors and the system and between system components. Also, we have the class diagrams to show the object classes and the associations between classes. State diagrams to show the system reacts to internal and external events. These 5 diagram types to represent the essentials of a system. We have 3 ways in which graphical models are commonly used. We may use graphical models as a means to facilitate discussion about an existing or proposed system. Incomplete and incorrect models are okay as their role is to support discussion. We may also use graphical models as a way of documenting an existing system, as models should be an accurate representation of the system, but need not to be complete. We may also use the graphical models as a detailed system description that can be used to generate a system implementation. As we know, models have in this situation, models have to be both correct and complete. Okay, I think we'll talk about context models the next time. Okay, thank you. We'll see you the day after tomorrow, Wednesday.